Close your eyes. Now imagine the Himalaya. Are they higher, lower, or gone entirely? 10 million years is a long, long time. It's long enough to grow deserts where forests once stood, and to create new seas where cities are now. This isn't science fiction. This is the future of Nepal, written in the slow, powerful language of geology. The engine driving this transformation is right under our feet. The Indian plate continues its relentless push northward, smashing into the Eurasian plate. This collision is what raises these famous peaks. Over the next 10 million years, that colossal squeeze won't stop, but it won't be a simple, straight-line push either. Faults will slip, entire mountain ranges will tilt, and massive blocks of Earth's crust will slowly rotate. Valleys we know today might widen into broad plains, while others could be lifted up, crumpled into entirely new ridges. The mountains you recognize, the familiar shapes of the skyline, will be rewritten grain by grain. Think of mountains like slow-motion glaciers made of rock. Their movement is just measured in millimeters per year. But as the land rises, it's also being torn down. The great Himalayan rivers, the Koshi, the Gandaki, the Karnali, are nature's sculptors. They relentlessly grind away at the mountains, carrying tons of ground-up rock and sediment south toward the plains. Wherever a river finds weaker rock, it will carve new, deeper canyons. And where the current slows, it will drop its heavy load, building up vast alluvial plains that will gradually push the coastline of the Terai further south. Entirely new islands, formed from clay and sand, could appear in the shifting river networks. In 10 million years, some of the river drainage patterns we see on maps today will have vanished completely. New ones will emerge, looking both surprisingly different and yet strangely familiar. Then there's the ice. Glaciers are climate's slow-motion clocks. If our world continues to warm, the Himalayan ice will retreat, stripping the highlands of their brilliant white caps and exposing the raw bedrock underneath to faster erosion. But if global temperatures swing the other way and a new ice age begins, the glaciers could expand dramatically. They would advance down the valleys, digging them deeper and carving out new geological features that could last for tens of millions of years. Either way, ice is a key player. It shapes the peaks and helps decide how quickly the mountains fall apart. The white crowns of Everest and Annapurna aren't permanent fixtures. They are temporary crowns, granted and taken away by the whims of climate. So it's a constant battle, a delicate balance between uplift pushing from below and erosion wearing away from above. If India's northward push remains strong, the highest mountain ranges will persist. Some peaks might even grow higher, while others collapse under their own weight. But erosion never sleeps. Over millions of years, valleys will deepen, steep slopes will round off, and some of the sharp, jagged ridges we see today will soften into long, rolling hills. The change won't be uniform. Instead, expect dramatic local transformations. Imagine a city that today sits on a valley floor. In 10 million years, that same location might be perched on an elevated terrace high above a new river, or it could be buried deep under layers and layers of river sediment. These geological shifts will also create new landscapes for water. A major earthquake could trigger a landslide that dams a river, creating a massive new lake that could last for millions of years. In other places, tectonic stretching could cause basins to sink, potentially forming inland seas if the climate and geography allow. The high central regions of Nepal might become home to a chain of long, deep alpine lakes, while the Terai could transform into a vast mosaic of wetlands and marshy plains where sediment slowly builds new land. It is amazing how tiny changes in elevation can produce enormous changes in where water collects and what kind of life follows it. And what about us? What trace will humans leave behind? 10 million years is a time span that dwarfs all of recorded human history. Our cities, roads, and temples will most likely be long gone, either buried deep under sediment, completely eroded away, or mineralized into fossils within the rock layers. Perhaps the only signs of our existence will be subtle scars on the land, faint outlines of ancient agricultural terraces, unusual chemical layers in the soil, or the stone ruins of a temple half engulfed by a newly formed hill. If humans or some successor species are still around, they would inhabit a completely different geography, perhaps living on river terraces that didn't even exist in our time. Our greatest monuments are fragile in geological terms, but the stories they leave behind in the rock can last for eons. 10 million years from now. It's a mind-bending thought experiment with gravity, water, and time as the artists. The future Nepal will be a patchwork of old and new. Some peaks will still stand proud, some valleys will be completely reshaped, and new lakes will gleam where towns once stood. The lesson here is that landscapes are alive. They are constantly changing, just on a timescale far slower than a single human lifetime. But every river, every glacier, and every fault line is writing the next chapter of Earth's story right now. We only have to learn how to read the rocks to begin to imagine it. The mountains we admire today are still making themselves, and in our own way, so are we. Thanks for watching.